Hello everyone, welcome to a new lecture of discrete mathematics. In this lecture, we are going to solve few exercise of Bayes theorem. So the problems we are solving in this lecture are taken from the book Discrete Mathematics and its Applications by Kenneth H. Rosen. So the first example, if we see that in the first example, it is said that there are two events E and event F in a sample space, and the probability of happening E is 1 by 3, probability of F is 1 by 2, probability of E given that F equal to 2 by 5. Now we need to find what is the probability of happening F given that E happened. So we need to find probability of F given that E, right? So if we use our equations or formula of Bayes theorem, so the formula will be probability of E given that F, probability of E given that F into probability of F, right? And what will be the divisor? It will be probability of E given that F into probability of F plus E can happen for F, or also E can happen when the F did not happen, right? So probability of E given that F prime into probability of F prime, right? Now if we see that what we are given, we have the value of probability of E given that F, probability of F, right? But we don't have the value of probability of E given that F prime and probability of F prime, right? But if we remember this probability of E given that F into probability of F plus probability of E given that F prime into probability of F prime, that means this part, this is equal to probability of E. Why? Because we divide it with the total probability. This is the total probability of happening E. If we look carefully, this is the probability of happening E when F happened, and this is the probability of E happening considering that F did not happen, right? So this is the total probability of happening E. So we can, as this is the total probability of happening E, we can write this formula as P of F given that E equal to P of E given that F into probability of F divided by probability of E. Now we have the value of probability of E, probability of F, and probability of E given that F. So if we put this value into our equation and solve, then we will get, let's calculate this. We will get 3 by 5, right? So our answer will be 3 divided by 5. So that's our answer. Now let's solve another example. In this exercise, it is said that suppose that Frida selects a ball by first picking one of the two boxes at random and then selecting a ball from the box at random. That means there are two boxes, right? So it means that there are two boxes, box 1 and box 2. So let's say that event A equal to box 1 box 1 and B equal to box 2, right? And it is said that we select the boxes randomly. So we can say that the probability of selecting box 1 is equal to probability of selecting box 2, which is 1 by 2. So we can say that probability of A equal to probability of B equal to 1 by 2. So this is our probability of A and B. Now it said that the first box contains 2 white balls and 3 blue balls, and the second box contains 4 white balls and 1 blue ball. So what is, we need to find the probability that Frida picked a ball from the first box if she has selected a blue ball. That means we know that Frida has selected a blue ball. Now what's the probability that this blue ball came from box 1 or the first box? So let's assume that x equal to blue ball, right? X equal to blue ball. So what is the probability of x given that we have selecting it from, we have selected the box 1 equal to, let's see that in the first box there are total 5 balls, right? 2 white balls and 3 blue balls. So that means there are total 5 balls, and out of those 5 balls 3 balls are blue. So the probability of selecting a blue ball given that we have selected the box 1 is 3 by 5. And similarly, probability of selecting a blue ball given that we have selected the box 2 is 1 by 5. Why? Because there are total 5 balls, and out of those one ball is blue, so 1 by 5. Now we need to find out that we know that we have selected a blue ball. What is the probability that it came from box 1? So what we need to find is, we need to find that given that x, what is the probability of A, right? So we need to find it. So if we use our formula of Bayes theorem, it will be P of x given that A into P of A divided by total probability of x, right? And the total probability of x is what? It is x given that A into P of A, but then again we can choose the blue ball also from the second box, right? So P of, so plus, one second, so it will be plus P of x given that B into P of B. Now we have the values. What we need to do is, we need to put these values into this equation and solve. So if we calculate, we will get 3 by 4. So this is our answer. So now let's solve the another question. In this question it is said that when a test for steroid is given to soccer players, taking steroids test 20% of the players not taking steroids tests positive. Suppose that 5% of the soccer player take steroids. What is the probability that a soccer player who tests positive takes steroids? So if we say that the S equal to the event that a player takes steroids, then probability of S is given, which is 0.05 or 5%, right? That a probability of a player taking steroid. Now there are all, if P of S is 0.05, then the probability of not taking steroid, or P of S prime, is 1 minus P of S the probability of S, which is 0.95, 0.95, right? So now there, what else we have? We have that 98% of the players taking steroids test positive. So if we say that X is the event that someone has been tested positive, so if X equal to positive, so given that he actually takes steroids, the probability of being tested positive is 98% or 0.98, right? 0.98. We also have that the probability of someone being tested positive is 12% when he actually does not take the steroids, right? So P of X being tested positive when he does not takes the steroids, or that means given that S prime, the probability of X equal to 12% or 0.12. So now we need to find out that what is the probability that a soccer player who tests positive takes steroid. That means we know that someone has been tested positive. So given that someone has been tested positive, what is the probability that he actually takes steroids, right? So if we use our formula of Bayes theorem, this will be P of X given that S into P of S, the probability of S, divided by the total probability of someone being tested positive, which is that someone can be tested positive while he actually takes the steroids, and he can also be tested positive when he does not take the steroids, right? So P of X given that S into P of S plus P of X given that S prime into P of S prime, right? Now we have all the values we needed. So we have all the values we need. So what we need to do is now we need to put these values into this formula and calculate to find out the result. So let's calculate. So the result is 49 by 163. So this is our result. Now let's solve another example. In this example, it is said that suppose that 8% of the patients tested in a clinic are infected with HIV. So if we say that H is the probability, is the event that someone is infected with HIV, then probability of H equal to 0.08, right? So now what we need to find out that suppose that when a blood test for HIV is given, 98% of the patients infected with HIV test positive. So what else we are given? Let's assume that being tested positive is event X. So we are given that probability of X given that H, or when someone is actually infected with HIV, we know that someone is actually infected with HIV, probability that he has been tested positive is 98% or 0.98, right? So 0.98, and we are also given that 3% of the patients that are patients not infected with HIV test positive. That means someone who is actually not infected with HIV, that means H prime. So given that H prime, the the probability of being tested positive equal to 0.03, 0.03, right? Now if we look at the question A, so in A it is said that a patient testing, we need to find out the probability that a patient testing positive for HIV with this test is infected with it. That means in A it is said that someone has been tested positive. So we know that someone has been tested positive. What is the probability that he is actually infected with HIV, right? So we need to find out the probability of H given that X. So if we use our formula, the formula will be P of X given that H into P of H divided by total probability of being tested positive, which is X given that H into P of H plus P of X given that H prime into P of H prime, right? Now we need to find the probability of H prime too, right? Because we have the probability of X given that H prime, probability of H, and probability of X given that H, but we don't have the probability of H prime. So how can we find it? We can see that we have the probability of H. So the probability of H prime equal to 1 minus probability of H. So P of H prime will be 1 minus 0.08, which is 0.92, right? So if we calculate these values, we will get 196 divided by 265, right? So this will be the answer of question A. So we are done with question A. Now let's see the question B. In the question B, it is said that a patient testing positive. So given that someone has been tested positive, or given that X, what is the probability that he is not infected with it? That means given that someone has been tested positive, what is the probability that he is not infected with HIV? So that means we need to find out the probability of X given that X, probability of H prime, right? So if we use the Bayes formula once again, so the formula will be P of H prime, P of X given that H prime, once again, so the so it will be probability of X given that H prime into probability of H, right? So probability of X given that H prime into probability of H prime divided by probability of X given that H prime into probability of H prime plus probability of X given that H into probability of H. So if we calculate this, we will get 69 by 265. So our result will be 69 divided by 265. So we are done with question B too. So now question C. In question C, it is said that a patient testing negative for HIV, what is the probability that he is infected with it? That means what we need to find now is see, it is said that we know that someone has been tested negative, right? That means given that x prime, what is the probability that he is infected with it? That means given that x prime, what is the probability of h? So if we use the formula will be p of x prime given that h into probability of h divided by p of x prime, the total probability of not of being tested negative, which is x prime given that h into probability of h plus probability of x prime given that h prime given that h prime into probability of h prime. So now if you look at the formula, we don't have the value of probability of x prime given that h and probability of x prime given that h prime, right? So how can we find this? See, what is the probability of x prime given that h? It means that someone is infected with HIV but tested negative, right? Someone is infected with HIV, given that someone is infected with HIV, someone he is tested negative. So how can we find it? Look, in the question it is said that 98% of the patients infected with HIV test positive. So that means if he is infected with HIV, there is 98% of the chance that he will be tested positive. That means the rest of the 2% chance is that he will tested negative. That means P of x prime, that means the probability of being tested negative when someone is infected is 0.02 or 1 minus 0.98, which is 0.02, right? So 0.02. And we also don't have the value of p of x prime given that h prime, right? So what is this? It is this p of x prime given that h prime is that we know someone is not infected with HIV and also he has been tested negative, right? So how can we find out? Look, there is 3% of the patients that are infected with, that are not infected with HIV tested positive. That means the rest of the 97% of patients who are not infected with HIV are being tested negative, right? Because if 3% of the uninfected people, but 3% of the not infected people has been if they are being tested positive, then the 97% of the people will be tested negative. So p of x prime given that h prime is 0.97, right? 0.97. So now we have the values. If we calculate this, we will get our result, which is, so we will get the answer, which is 4 by 2235. So 4 by 2235. So that's our question C. Now if we look at the question D, it is said that someone has been tested negative. That means given that x prime, what is the probability that he is not infected with it? That means given that x prime, what is the probability of h prime? So if we again use the formula, so our formula will be p of x prime given that h prime into p of h prime divided by p of x prime given that h into p of h plus p of x prime into h prime p of x prime given that h prime into p of h prime, right? So if we calculate this, we will find the result, which is 2231 divided by 2235. So our result will be 2231 divided by 2235. So this is our result of question D. So now the final question. In this question, it is said that suppose a Bayesian spam filter is trained on a set of 500 spam messages and 200 messages that are not spam. So there are total 700 messages. Out of that, 500 are spam and 200 are not spam, right? So if let's assume S is the event that the message is spam, so probability of S equal to 500 by 700, right? Why? Because there are 500 spam messages and 700 total messages. So 500 by 700, which is equal to 5 by 7. And also we are given that not is the probability that the spam is not spam, p of s prime equal to, p of s prime equal to 200 by 700, right? 200 by 700, which is 2 by 7. Now if we look further, we will see that the word exciting appears in 40 spam messages and 25 not spam messages, right? So if we assume that the event of occurring or appearing excite or the word exciting is event E, then probability of E given that S or that the message is spam, in that case the word the probability of appearing the word exciting is 40 divided by 500. Why? Because there are 40 spam messages in which the word exciting appears and the total spam messages are 500. So it will be 2 by 25. So this will be 2 by 25. And we are also given that in 25 not spam messages the word exciting appears. That means given that the message is not spam, the word exciting appears. So given that S prime, the probability of E is 25 by 200, right? 25 by 200, which is 1 by 8. So now we are being asked that if an incoming messages would an incoming message be rejected as spam if it contains the word exciting and the threshold for rejecting spam is 0.9. So we are not looking into the threshold right now, we will look into it a little bit later. So at first we need to find out the probability that if the message is spam, what is the probability of that message being spam if the word exciting appears. That means we need to find out p of s given that E, that means the word exciting appears. Now what is the probability that the message is spam? So if we write the formula, it will be p of E given that s into p of s divided by the total probability of the word exciting appears, the total probability of appearing the word exciting, which is p of E given that s into p of s plus p of E given that s prime given that s prime into p of s prime, right? So if we solve, now we have the values. So if we calculate, we will get the result will be 8 by 13, 8 by 13, 8 by 13, which is equal to 0 0.615, 0 0.615. So the probability that if the word exciting appears, the probability that the message is spam is 0 0.615. So we are asked that if this message will be rejected as spam or not. So what is the probability that this message is spam, given that the word exciting appears? It is 0 0.615, right? And the threshold, if we see the question, it is said that the threshold for rejecting spam is 0.9. That means if we need to flag that message as a spam or reject that message as a spam, then the probability of that message being a spam have to be greater than or equal to 0.9. But 0. Our probability of this message is being spam is 0.615, which is less than 0.9, right? So this message will not be rejected as spam. So that's it. Thank you. And if you think that this video was helpful, please like and subscribe this video. That's it. Thank you.